1-2, analyzing graphs of functions and relations. So the first problem is meant as a warm-up. So if you could go ahead and pause the video and try this on your own paper, you're going to find the domain and range, and you are going to use interval notation. So again, go ahead and pause this and try it on your own. So now that you've had a chance to try finding the domain and range on your own, we're going to work it out together. So when I am looking at my domain, I'm looking at everything that x can be. So I am looking to the left and right. And this is my x's. And I can tell on my left that my x's go to negative infinity. And on the right, it stops at 2 and it includes 2. And so my domain would be a soft parenthesis at negative infinity. Infinity and negative infinity are always soft. They're unbounded. You can't actually reach infinity. And on the right, because the 2 is a filled in circle, it can actually equal 2. So I would have a hard parenthesis or a bracket. Then I want to look at my range. So my range is my y's. That's my up and down. And I see as I go down on my graph again, it goes down forever. So that's going to be negative infinity. But as I go up, my graph tops out right here. And that's at 5 on my y-axis. So my y's go from negative infinity to 5. And again, we'll have a soft parenthesis at negative infinity and hard at 5 because we can actually equal 5. That's our max. Again, domain is my x's and range is my y's. So we're just continuing to analyze graphs today. So the first one, we're asked to approximate the y-intercept. So a y-intercept I can tell right from my graph, it's where I cross my y-axis. So this would be at 4. And then I'm asked to prove it algebraically. So at my y-intercept, my x is 0. So to prove it algebraically, I'm going to find f of 0, which would be 0 squared minus 4 times 0 plus 4. And so all those zeros basically cancel out, and we're just left with 4. So we have proved it algebraically. For the third one, we're going to approximate zeros. So remember, when we say zeros, we're really talking about x-intercepts. So I want to look at my x-axis and find everywhere that the graph crosses. And looking at my scale, I've got one at 0. Halfway between 0 and -2 would be a -1. This would be a positive 1. So I have my zeros here. My zeros are -1, 0, and +1. And then if I'm going to find them algebraically, to find a y-intercept, I let x equal 0. To find an x-intercept, I need to let y equal 0. So I'm going to put a 0 in for my f of x. F of x is the same thing as y, and I have to solve. So first I'm going to factor out an x. X squared minus 1 is difference of squares. I can keep factoring. I don't have a lot of space here. And then I need to solve. So either 0 equals x, or 0 equals x minus 1, or 0 equals x plus 1. Remember, we still have to write out all those steps, but we don't have to show the adding and subtracting. And so I have just proven I get 0, 1, -1. And let's just go back really quick and make sure that we add in to find a y-intercept that we have to let x equal 0. We probably want to have that in writing. Just a good reminder, some of us have been about 6 months without a math class now. So there's a lot. So we've got different types of symmetries. And so we're going to look at what type they are. And for x-axis, it's a line symmetry. So you could reflect it over a line. Let's see, my y-axis is also line symmetry. Again, you're reflecting it over the line. But the origin is point symmetry. So it's really like rotating the graph around a point. So different kinds of symmetry. Y-axis symmetry is also called even. And point symmetry is also called odd. So we're going to talk a lot about even and odd. That's actually what you're going to be tested on. So a big portion of the homework is looking at x-axis, y-axis, and origin symmetry, but know that on your test, we're going to narrow that down and only really worry about even or odd. So we want to look at some models of that. So if I want to make a graph that is reflected over my x-axis, I could make a parabola like this. And then if we think about points on those, this point would be over x and up y. And this point would be also over x, but now it's down y. And if we have x-axis symmetry, we also don't have a function, right? So when we plug in a number, we get two different answers, which we don't really like in math. So that's why that's not like one of those specific kinds of symmetry that we're concerned about, like even and odd, because it's not a function. Y-axis symmetry, I would need to go ahead and draw my coordinate plane again. And then this time I'm going to draw a parabola that's facing up. So my line of symmetry is right down the middle. So on one side, I have a point that's over x and up y. And on the other side of my graph, it's back negative x and then up y. So when I plug in, that's really messy. Let's fix that. And maybe we should say substitute. Sounds a little bit more mathy. So when we sub in plus or minus x, and we're not actually going to use an x, we're going to use numbers, okay? And the answer, so in this case, if I have a negative x or a positive x, my answer either way is y. So, and answers are exactly the same. So even is exactly the same. Okay, and then for odd, and I feel like I can probably squeeze it in here. So here's an example of origin symmetry, where you can see if I take this part of my graph and that quadrant 1 and swivel it around, it would match up to quadrant 3. So here I have an xy and a negative x, negative y. So here, if I sub in a plus or minus x, my answers are opposites. So odd is opposites, or origin is opposites. They all go together. So even or y-axis is exactly the same. Odd or opposites are the same as origin. Those are all together. And then remember that x-axis symmetry, because it's not a function, we don't have this other special name for it, and we're not as interested in it. So for this problem now, we're going to look at the graph, and we're going to just tell what kind of symmetry it is from the way it looks. And then from there, we're going to go ahead and prove it. So this algebraically, we're just going to be plugging in numbers. We're not going to be using letters like the textbook does. So I just want to make a note here that we are showing work as demonstrated in class. So I do not want you doing what the book does, where they plug in X and Y. All right, so this first one, I can tell that my axis of symmetry would be right here. So I have y-axis symmetry, which again is even. And then I want to plug some numbers in to prove that. The only thing we have to be careful about with plugging in numbers is we don't want to plug in things that are zeros, because we can't tell if 0 is opposites or same or any of that stuff, right? There's no negative or positive zeros. So we need to plug in a number that will not yield 0. So normally I just choose x equals 1 and x equals negative 1, but if I get 0 as an answer, then I would pick 2 and negative 2. I have to pick something else if it doesn't work. So when x is 1, my function, again, is y equals x squared minus 4. So then y would be 1 squared minus 4, which is 1 minus 4, which is negative 3. So if I get Is that minus 4 or was that something different? Oh, no, it's x squared plus 2. All right. Thinking about the last problem we did. So if it is x squared plus 2, I think I'm actually going to get a positive 3, interestingly enough. So x squared plus 2, so 1 squared plus 2, glad I double checked, 1 plus 2, so y equals 3. And then if I have a negative 1, I would have y equals negative 1 squared plus 2. We know negative 1, the quantity squared is also 1 plus 2, and so we get 3 again. So because these are exactly the same, we have y-axis or even symmetry. On the second one, I can tell that this part of my graph, if I rotate it around the origin, I would end up over here in quadrant 2. And so this is going to be origin or odd. And I like putting both of those down because I want to remember. And then same thing again, I'm going to start out with 2 different numbers for x. And I just use, like I said, x equals 1 and negative 1. Unless something happens, if I plug it in and I get a 0, then I know I need to go on and pick a different number like 2. So that means I would be using, let's see, my equation is xy equals negative 6. So if I put 1 in for x, I have 1 times y equals negative 6. And so y equals negative 6. If x is negative 1, then I have negative 1 times y equals negative 6. And so y equals positive 6. So because these are opposites, I have just proven that I have origin symmetry or odd. So I guess the way we would say it is our function has origin symmetry and it is odd. So odd isn't really a type of symmetry, it's just a classification. They're odd or they're even. So for our last example, we're going to look further at what this means. We're going to determine if the function is even, odd, or neither. And we're going to just do this with algebra. And then we can also go back and graph our functions as well. So this one's going to require a little more work. So I think first I'll probably graph. And so, because it says graph first in direction, so put a 0 in here. Let's find our x-intercepts. So now I have to factor out an x squared from the first two because I'm doing a factor by grouping. I have 4 terms. Oops, it should be an x minus 3. My kid came just downstairs a second ago to help me out and yell stuff at me, and I got sidetracked there. So the second two, I'd factor out a negative 1 because I know these need to both be an x minus 3. So then I can keep factoring x squared minus 1 times x minus 3. So x plus 1, x minus 1, x minus 3. All right, so now I have 0 equals x plus 1, 0 equals x minus 1, 0 equals x minus 3. So hopefully this factoring is easy for you. We do a lot of this in Algebra 2, but I know you might be a little bit rusty. It should come back quickly though. The other thing I would look at when graphing it, this is x cubed. And so it's odd, or not odd, it's third degree is what I'm trying to say. Third degree, and it's positive. And so I know my graph should be this shape. We need to know that also. So now I would go ahead and graph it. So here's my coordinate plane. Here's 1, 2, 3. So I've got a 0 at 1 and a 0 at 3. And I have a 0 at negative 1. And let's see, my y-intercept would be the positive 3. Because if I put zeros in for all my x's, they would cancel out. I'd be left with positive 3. So I'm going to make my y-intercept as well. And then I'm just going to do the best I can to connect those points and make a graph. So I can tell already looking at this, it's not going to be, I mean, when you look at just that parabola shape kind of in the middle, it almost looks like y-axis symmetry, like it could be even. But I've got this extra hump down here that's not going to reflect. And then it almost looks like it could be point symmetry or origin symmetry around the origin, but only if I reflected it around maybe 1 instead. So it really seems like this should be neither. And then we're just going to go through and we're going to check that out with algebra. So if I was to use, normally I said I would use x is 1 or negative 1, but I know that those are both zeros, so those aren't going to work. So I need to pick a different value. So I'm going to use x equals 2 and x equals negative 2. So again, when x is 1 or negative 1, those are zeros. And I can't tell at that point, I can't find the relationship I'm looking for. I can't tell if my answers are the same or opposites because 0 is just 0. So I need to pick a different number. So we can't use plus or minus 1 because they are zeros. So that's an important thing on this. So when x is 2, let's see, my function is going to be 2 cubed minus 3 times 2 squared minus 2 plus 3. So we're just going back to that original function. We're putting in 2. So this would be 8 minus 3 times 4 minus 2 plus 3. Let's see, that's 8 minus 12 minus 2 plus 3. So let's see, 11 minus 14, negative 3. And now I'm going to let x equal negative 2. So I need to figure out negative 2 cubed minus 3 times negative 2 squared. And then it's going to be minus a negative 2 plus 3. So let's see, negative 8 minus 3 times 4 plus 2 plus 3. So I feel like that should be negative 20 plus 5, negative 15. So these are completely different, 3 and 15. There's no relationship there, so I can tell it is in fact neither. If I got 3 and negative 3, then I could say odd. If I had negative 3s for both of them, I would say even, but there's no relationship there. So I want to think about x squared minus 4. Lots of different ways to graph this. I know that my y-intercept is negative 4. I know I have a parabola that's going to be right side up because it's not negative. If I was going to go ahead and factor this, that would give me my zeros. So I can kind of tell a lot about this right away. Oops, x minus 2, x plus 2. So let me go ahead and graph that. And my page keeps jumping for some reason. I guess I need to make this longer because it needs to go down to negative 4. 1, 2, 3, 4. And my x-intercepts are 2 and negative 2. And then I just draw my parabola. So we're really after kind of fast graphing techniques, just getting a picture of what something looks like. So this is definitely reflected right down the middle over my y-axis. So I would say even. And then I need to prove it algebraically. So I'm going to start with x equals 1 and negative 1 again. Because I can, because they're not zeros. 2 and negative 2 wouldn't work though. And again, my function is x squared minus 4. So that means I'm going to do 1 squared minus 4. That would be 1 minus 4. That would be negative 3. And on the other side, negative 1, the quantity squared minus 4 would be 1 minus 4 would also be negative 3. So those are, again, exactly the same, which justifies that answer of even. So even is exactly the same. So big concepts today. I definitely showed you some quick graphing that you might have forgotten. On your homework, let me go ahead and go to the next page. On your homework, they're going to ask you to use a graphing calculator on some of them. You could use the app Desmos, or you can just skip graphing. What I'm going to have you be doing on your test is just telling me either even or odd and then backing it up with math like I did. And so you're not going to have to really graph anything on these. But I do think being able to graph polynomials like I just showed you is really important. The exit ticket that you do on 1-2 will give you a graph and it will ask you to respond even or odd, and then you'll back it up with math, just like we did on number 6. So these are going to be the ones that are like your quiz or like your exit ticket. So these are the problems I really expect you to be able to do. Please let me know if you have any questions.